Hi, my name is Leilani Natividad, and I will be doing my neural pathway sensation video on the sound sensation. So we're gonna try to adjust this here. Okay, scoot it forward a little bit. Okay, I think that's about as close as we can get. So actually, let's zoom in. Can we zoom in? Oh, okay. Actually, we'll start right there. I think that's a good place to start. Get my pencil. Okay, sorry about the delay. So, like I said, I will be doing my neural pathway sensation video on the sensation of sound. So let's get right to it. So, alright, so the pinna, which is located out of the inner ear, which is this part up here, captures a sound in front of you, or any sound, but in this context, we're going to be if someone's like, if the sound is coming from right in front of you. So the pinna captures that sound in front of you, which then travels along the ear canal, which is also known as the external auditory meatus, which is this section right here. Okay, so the sound will eventually hit this portion right here, which is known as the tympanic membrane or the eardrum. And the eardrum vibrates, or it will vibrate, which will then result in the malleus, incus, and stapes, these three little bones right here, also known as the ossicular chain. It connects the middle ear and the inner ear. They will vibrate as well, which increases and amplifies the sounds of vibrations. The sounds are then sent to the cochlea, which we're now considered, the cochlea is in the middle, not the middle ear, I'm sorry. The cochlea is located in the inner ear. So we're now finally inside the inner ear. The cochlea is right here, this little spirally shaped thing. So inside the cochlea, there is fluid, which results in the sound vibrations being created more into like sound waves. Also inside the cochlea, there are hair bundles which sit on top of hair cells, and these sort of like ride the waves. And at the bottom of the hair cells, there are chemicals created which bind to the auditory nerve cell, which is, okay, so it says auditory, so this is the auditory nerve cell, also known as the cochlear nerve, auditory nerve, they're synonymous. And it's important to note that the auditory or cochlear nerve is a part of cranial nerve 8, which is the vestibulocochlear nerve. So the auditory or cranial nerve is responsible for hearing, while the vestibular part is more for balance, equilibrium. Now, from here, we'll say the auditory cortex. I'm sorry, the auditory nerve. From the auditory nerve, the electrical signal will travel. So from our cranial nerve 8, it'll course to the midbrain. So let's scoot up a bit. Oops. Come on. Okay. So it'll travel to the midbrain, which is right here. So it'll travel, like it shows, it'll travel up to the midbrain. Then to the temporal lobe, so obviously we said it travels from the auditory nerve to the brain. So we're going up to the brain, and more specifically, I believe, okay, come on. Okay, so now let's look at this picture of the brain. So more specifically, which part of the brain is we're going to be looking at the temporal lobe, which is this region down here, if we're looking at it from a more lateral view. And specifically which part of the temporal lobe it travels to is the auditory cortex. And this is the auditory cortex, as we know, is the main area responsible for processing auditory information. And as we learned in the lecture this week, when signals arrive at the auditory cortex of the temporal lobe, the impulses have preserved the place frequency arrangement of the basilar membrane. So just a little note there is, we know it's organized to where certain sounds of certain, I guess, pitches will be looked at in this part of the brain. So yeah, so just to recap, let's go back up. So we went from the sound being captured in the pinna to the the sound will be captured in the pinna, travel through the middle ear of the external auditory meatus, hit the tympanic membrane, which will then vibrate both the tympanic membrane, the malleus, the incus, and the stapes. That will travel to the inside ear of the cochlea, where our hair bundles and hair cells will it'll go from being a wave to creating chemicals and then send the electric signal to the auditory nerve, which will then send it up through the midbrain all the way up to the brain, specifically the temporal lobe in the brain, and even more specifically to the auditory cortex in the temporal lobe of the brain. And I believe that's about it. So thank you.